Mr. Medlock, and this is assignment number 2. So for question number 1 of assignment 2, what we had to do was create this star shape. It was pretty trivial because last week we created the same star shape. All I had to do for this time was edit the color variables. So yellow, 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 green, blue, red, fuchsia. And what this does is create a gradient because it uses the formula that you showed us last week in your lecture to compute exactly what color it should be where. So moving on from this question, we have question number 2. Question number 2 was similar, but instead we had to make solid shapes and make sure they were not gradients. How this is accomplished is by creating a second vertex in each of these locations right here, 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 and here, and just assigning those colors to be match the colors that are being reached out to by that vertex on the end. And this is it's visible down here, the 5, 10, 11. These are the new vertices created, 12, 13, 14, and 15. So these are the new edges, and they're created with their own unique colors. So that's it for question number 2. Question number 3, what we did for this one was we actually flip-flopped the colors and the vector in the actual structure. So color is first, position is second. And this is accomplished not by changing the shader at all. As you can see, the shader is not changed at all. But what is instead changed is the layout of the vertex buffer. So it knows that the color is first at 0, and it knows the position is second on the next aligned element. This is just a macro that explains that, and you can, you can see that right here. So yeah, that's how it works. And if you go ahead and boot it up, you can see that it does render. It does make the actual shape that we desire. And then in the fourth question, what we had to do was create. I changed the color. But what it does is it allows you to change the color by just going down here and editing just the color, so you can change it from blue to red. And how this works is because the color is stored in a constant buffer, and the constant the shader constant takes the data from the constant buffer when it's already down in the GPU, and it applies it to the shader constant. So how that works is this is the constant buffer, C buffer. It has the active color with of 2, and then these are our shader constants right here. So what it does is when it goes out of the pixel shader, it sends the active color, but it sends the color of the actual shader constant that it's being set to, or that is in this that's in this data structure. So here it's the color number, and in the actual CPP file, it is indicated right here. So that's how that works. As for the further work, the first question is what's the difference between the constant buffers and the shader constants? Now, in my research, I wasn't able to get anyone to tell me exactly what a shader constant was. They wanted to use a shader constant to explain to me what a constant buffer was. So it is my understanding, and correct me if I'm wrong, that these are the shader constants. The shader constants are what is being sent through the pipeline every single time. It goes in the vertex shader, and it goes out the pixel shader. And now it is also my understanding that a constant buffer is tidbits of information, like all the different variations that are sent down to the GPU and can be stored in the GPU, but can also modify the shader constants. So this would be a constant buffer, and these would be the shader constants. So you can have as many constant buffers as you want, and that's indicated by sending them down to different registers. And the default one is register 0. So if we go back to the CPP file, you can see that it's binding this as a vertex buffer. I don't know. I hope that didn't do anything. And then the other one is, the other one is binding as a constant buffer, and this is bound as an index buffer. So that's how these know what's going on, as well as the macros here allow for position and color, so it knows to store those in there. So that's it for that question. The second question is this one. Now I did this, I accidentally lost the file, but basically from my understanding is that this is applied to the actual vertices that are in that vertex buffer, and those are the only things that are going to be sent to the shader pipeline, or to the actual rendering pipeline. It looks like in here there's either another shape over the top of it, or the background itself is being sent to the rendering pipeline because this design is being applied to the entire thing, which you wouldn't want to have that happen. You wouldn't want to send this shape to the rendering pipeline and then have it affect the entire area around it. So I believe that that's the problem, is that you want to instead make a brand new square shape and apply that shader constant, or that this math, to the entire shape that's on the outside of the actual triangle. Whereas in this one, only the triangle, only these vertices are being sent to the rendering pipeline. So that is why it only applies, the shader only applies to the shape that's actually in the rendering pipeline. But yeah, that's going to be it for this week, and I'll see you in class. Thank you.